Okay, so that's reducing fractions from the other day. There are actually rules that we have that make this a lot easier. So those are our rules of exponents. We are talking about the product of powers. What does the word product mean? What does the word product mean, Nate? Right, we're multiplying them, right? If you notice, a to the m power times a to the n power, these have the same base, right? That's the same. Because they're the same base, we have this rule that says if you have a to the m power times a to the n power, you just take the base and you add the exponents. And I will tell you why that's true. Because if I have, let's just say, m to the third power times n squared, how many m's do we have here? So we have m times m times m. Sorry, this is going to be another m, not n. M to the second power. How many m's do we have here? Huh? So when you multiply these together, you get m to the what power? Fifth power. It's kind of like at the beginning of the year when I had you guys do x times x. What is that? What's x times x? Jared?
X squared.
X squared. So if they have the same base, you add the exponents when you're multiplying them. You're going to get a bunch of different rules here this chapter. So number 1, it says 4 to the 7th power times 4 to the 11th power. Are they the same bases? Yep. The base is just written down again, and you add the exponents. So what do we get? 18. Please do not multiply the bases. The rule says keep the base and simply add the exponents. Number 2 is a little bit different just because there are coefficients out front. But we can multiply coefficients, can't we? Why, yes, we can. So 2 times 7 is 14. This is x squared, and that's an x to the 6th. They're the same base. So we're going to write x to the what power? 8th. You just add your exponents. You got to ask yourself, do they have the same base? Yep. So the rule says to take x and add 6 plus 13, which is x to the 19th power. Number 4 says b squared times b to the 4th times b. Are they the same bases?
Yeah.
You can only do it when they have the same bases. So this means take the base and add the exponents. Well, what are the exponents? Raise your hand and tell me what are the exponents, Maria? 2 plus 4 plus 1, right? You can't see it, but there's a 1 there. So we get b to the 7th. Is that kind of easy? What if I have something like 3m to the 9th n times 4m squared n to the 4th? 3m to the 9th n times 4m squared n to the 4th. Notice this is all multiplication, isn't it? Every part in here is multiplication. So, multiply your coefficients. What do we get? M and M are, that's not the wrapper. M and M. It's a variable. They're the same, so we add our exponents. So we get m to the what? N's are the same base. We're multiplying, so we add the exponents with the n's, and you get n to the... Kind of easy, isn't it? If I have a to the 6 over a squared, how many a's are on top? How many are on bottom? There's 6 in the numerator, 2 in the denominator. How many of them cancel? 2. So where do we have a's left? Where? The numerator. So we get a to the what? 4th. How do you think you're going to get a to the 4th using a rule? If you are dividing, quotient means to divide, what do you think you do to find the new exponent, Seth? Yep, you got to take the denominators up to the numerator and subtract. You're right. So the rule, a to the m power over a to the n power. Notice a's are the same bases, right? The rule is to bring that denominator exponent up and subtract it from the numerator's exponent. So it's a to the m minus n power. So look at number 5. It says 6 to the 8th power over 6 cubed. Are the 6's the same base? Yep. So what we're going to do, and I want you to show me what you're doing when you do these. Take 6 to the 8 minus 3 power, so we get 6 to the 5th. And the reason I'm telling you guys to show your work on that is because we get rules with negative exponents here in the next day or two. And you will have different rules, same rules, but you're going to get yourself confused. Don't 6 and 7 look just like what we did the other day? We are going to divide the numerator and the denominator by what? What's the common factor? 3. And then we're going to, what do we get on the numerator? 3 divided by 3? 1. And the denominator? 4. Show me your rule. Are the x's the same base? Yep. So we're going to take x to the 7 minus 3. So what is my answer going to be? Well, I'll help you out. It's going to be x to the 4th over 4. Could I put a 1 in front of the x to the 4th? Yeah, I could, but it's not needed. You guys try number 7. What is the greatest common factor between 14 and 6? Jared? So we're going to take a 2 out of each of these. What do I have left in the numerator? 14 divided by 2 is? 6 divided by 2 is? And we're going to take x to the 16 minus 11. So what should my final answer be? What's my final answer going to be? Maria?
7x power 5 over 3.
There it is. Should I make that a mixed number? No, don't do that. Remember that rule that says, according to the order of operations, if it's a fraction problem, you simplify everything in the numerator and then the denominator, and then you divide, right? So we're going to work with the numerator first. The coefficient here is 4, right? What's the coefficient here? What? 1. 4 times 1 is? Are these the same bases? M to the 3rd, m to the 4th? So we add their exponents, right? 3 plus 4 over 12m squared. So it's really 4m to the 7th over 12m squared. Now we have one simple dividing problem, and that takes us back to the rule we just did. So we need to divide the greatest common factor of both of those, which is 4. Are these the same bases? M to the 7th and m to the 2nd? Are those the same bases? Yep. So on the numerator, 4 divided by 4 is 1 over 12 divided by 4 is 3. We're going to use our rule, m to the 7 minus 2 power. And we get a final answer of m to the 5th over 3. Let's look at the numerator first. We got to simplify up here. The coefficient here is 6. What's the coefficient with m? 6 times 1 is? Are these the same bases? What's the power on the m here? 1. So we're going to do 6m to the 5 plus 1 over 15m cubed. Well, that's really 6m to the 6th, isn't it? Over 15m cubed. Now we have one fraction. What is the greatest common factor between 6 and 15? 3. So we're going to divide each of these by 3. So 6 divided by 3 is 2. 15 divided by 3 is? Now we have to use our rule here. M to the 6th over m cubed. They're the same base, so we'd say m to the 6th minus 3. So what's my final answer? It's going to be 2m cubed over 5. We are going to take the 1 in front. 1 times 10 is 10. These are the same bases, so I'm going to do n to the 3 plus 6 all over 5n cubed. So that's really 10 n to the 9th over 5n cubed. Greatest common factor between these? 5, right? So we get 2 over 1. They're the same bases here. So we take n to the 9 minus 3. So what's my final answer going to be, Hudson?
2 to the 6th over 1.
Yep, and can I just write 2n to the 6th?
Yeah.
Yep, because everything, these are all rational numbers, aren't they? Like when it's over 1. So look at this problem here. You notice we've been talking a lot about rational numbers. Rational number is any number that can be